So in this video, we look at a continuation of a data set that we have used in the past and we will continue using in the future. So if the data makes a little bit of sense to you, this is your Suntan lotion data off of which you made your Excel assignment 2B. So you have the sales data here, you have the advertising dollar spent, and you have the average temperature, right? And you also have some very basic summary stats like the mean and the standard deviation that is computed for each of those data columns. So what we want to do here is try and take a look into how Z and some other features within Excel can be used to tell a more interesting story. Okay, so when you look at the Z-score, that is no different from the concept of a Z, right? So we have already learned that X equals mu plus Z sigma. So Z becomes X minus mu over sigma. That's how you compute Z. And in essence, that's what you see from the comment box for Z-score. That's what your Z is, X minus mu over sigma. And then there is a specific column called likelihood of occurrence, which basically all you're trying to see is what's the likelihood of getting a sales figure, especially in that first week, let's say, of 669, right? Likelihood of getting a sales figure of 669 or below. And this is the area to the left of your Z value. And we will come into this one as we compute the corresponding likelihood values. So let's start off with the Z-score. Your Z is in essence, as we said, your X minus mu over sigma. So when you compute that, you do equals, and then you have the B2, which is your X minus your mu, and you would want to put this in parenthesis. Divided by your sigma is the standard deviation 24, which is your B16. Also understand that when I captured this value for the remainder of the weeks, my mean and standard deviation do not change for any of those values. And therefore, what I can do is I can take my cursor on B15 and I can use my F4 function to make that cell constant. I can do the same thing for the denominator, which is my sigma, because it's the same sigma and mu for all of those data points. So that then gives me a Z-score of negative 1.18. And so if I take my cursor to the rightmost corner of that cell, as you can see, the cursor changes from plus sign to a very pointed plus, and I scroll those down, it basically takes into consideration all of the others as well. Okay, and so these are my Z-scores corresponding to my sales figures. Now, what does this Z-scores mean? Let's look into the first piece of the puzzle. Okay, so the first piece of the puzzle, and I'm going to highlight this just so that we understand what's going on. Okay, so in the first week, my sales was $669 or $69,000, let's say. We are looking at thousands of dollars here. So the corresponding Z-score is negative 1.18. So based off of what we have learned, if you put that into practice, this is your normal distribution of sales. That has a mu of 697, if you recall that value there, and a standard deviation of 24. So your 669 is to the left of 697, which is somewhere here. So naturally, if you draw a corresponding Z. Your Z value for your mean of 697 is 0, because by the very definition of Z, it measures the number of standard deviations that a certain point is away from the mean. And then for 669, its corresponding Z value will be a negative value, and lo and behold, that value is 1.18 that we have already captured, because that's what we have done. We have basically applied Z equals x minus mu over sigma. We have taken the value of x being 669, mu is 697, sigma is 24, and that becomes 1.18. So now the likelihood of occurrence, as we see this, of getting a sales figure of 669 and below is essentially this area. That's the likelihood of occurrence, right? That's where the probability piece comes in, which is the same as this area. And we all know that it's a very easy process of finding this when you look up negative 1.18 on the Z table. You'll find the corresponding area under the curve. So if I open up my Z table and I look up negative 1.18, my negative 1.1 is here, 0.08 is here. So they superimpose at this point of 0.1190, which basically 0.1190 then becomes this area, 0.1190, which is the same as this area, which tells you that there is an 11.9% chance that your sales in this week will be $669 or $669,000 or less. 11% chance. Okay, that you are going to make a $669 of sales. Okay, so 11.9% chance of reaching $669 of sales. So you can do the same thing using the Z functions that you have learned in Excel. You type in equals, NORMSDIST. You put in the first parenthesis. It asks you for the Z value. Your Z value is negative 1.18. We won't hard code anything. We will use cellular reference, which is C2. We choose that cell, close the parenthesis, hit enter, and it turns out to be 11.88%, which is the same as 11.9, close to that. Okay, so if I have to make this a decimal places, 1 decimal places, then that will change into the same idea. So that's basically how you capture the likelihood of occurrence, and that same process applies to all of these others. Okay, so if I take away the fill for that specific column, that tells me that for week 5, I have sales of 759, that is covering 99.57% of my overall demand expectations. This sales figure of 669 is covering only 11.88% or 11.9% of what I would want to cover. This entire area under the curve is your entire coverage, right? As a sales manager, you would want to see as much of it as possible. And then the question then becomes, how risk averse are you? Which of these weeks can you really say are good weeks versus which are bad weeks? Okay, so what amount of coverage do you want to actually achieve in your weekly sales that depends on who you are as a salesperson. Now, what we can do is, this is where we can make Excel a little bit more colorful in trying to appease our risk averseness. So as an example, um, if Dr. B is the um, sales manager, and this is a suntan lotion, so um, it's a seasonal product, and I'm trying to see, as long as I meet 65% of the area is covered, then I will consider that as a good sales number. Um, if that is not covered, then those are the specific weeks that I have to really concentrate on in terms of what happened, what went wrong, and so on and so forth. Right? So imagine that 65% is my risk threshold. Okay. So what I can do is I can choose all of these column points. Okay. And under the home ribbon, you see something called conditional formatting. So I can look into conditional formatting, and I can say highlight cell rules, and I want to highlight those cells that are greater than 65%. Okay. And because those are the better weeks for me, I want to put them with a green fill with dark green text, green being a go and red being a no-go. And when I hit OK, then this produces a more pictorial view that tells me that weeks um, 5, 8, 12, and 13 are the real breadwinners for me. These are the weeks in which I'm comfortable with the sales. The other weeks, not so much. I can also do this in a different way by looking into less than a certain number. So this is where I say this is green, this is all okay. What is an absolute not okay for me? And this varies from one sales manager to another. And that's where the risk averseness comes. This is where, and I have said this from day one, that analytics has a lot of science into it, but there is also art. There is also your way of expressing yourself. And so you can look into the um, lowest performing weeks. And so the reason I chose the strongest weeks is that now you can start looking into that weekly number, tally it with advertising, tally it with the corresponding temperature, and ask yourself what's going on with these specific weeks. What's going on here that is not happening um, with the other weeks. Okay, and so that then allows us to look at this data set from a very different angle and allow us to make decisions based off of this. Once again, everything we discussed so far, something very simple as is the application. Nothing too complicated, but um, understand that this is the basic, the bare bone essential of statistics. These are the bells and whistles. Everything else builds from here. As long as you can understand the concept of a Z, you can apply it to so many different settings. Opportunities for leverage is tremendous.